Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 applied students who are studying for the June EQAO. It is video number 9. In this series of videos, we look at questions that were asked in last year's June applied EQAO. Those questions are available at the following website. As you watch the video, if you have any questions about my math, or if you would like to see more help on a particular topic, please post in the comment section. Let's look at the first question. So we're on to number 31. It says use the Pythagorean theorem to find the length of the diagonal in the rectangle below. So the diagonal is shown to us. It's this line here that goes from corner to corner and cuts a rectangle in half. And we know because it says to use the Pythagorean theorem and because it says it's a rectangle, we know that this must be a 90-degree angle. So therefore, if I keep going, I can highlight for you the triangle that we're going to use the Pythagorean theorem with. So here's the Pythagorean theorem, and obviously you know you must have this memorized. C squared equals A squared plus B squared. Now, the most important part of using the Pythagorean theorem is properly identifying the hypotenuse. The hypotenuse is opposite the right angle, so in this case, the hypotenuse is the side that I'm looking for. We're going to label it C. The other two sides are A and B. It doesn't matter which one's which. So now I'm going to substitute the values that I know into the formula. I don't know C, so I still say C squared, but A is 80, so 80 squared. And B is 55, so 55 squared. So now I'm going to do this math. So using the rules of Bedmas, 80 times 80 is 6,400. 55 times 55 is 3,025. Keep going, add those numbers together. C squared is 9,425. Now I have C squared, so to find C, I need to take the square root. So in your calculator, taking the square root of 9,425 gives you 97.1. And if you round a little further, you'll see that that's clearly B. Okay, so let's move on to the next question. It says Hannah works painting sealant on driveways. Now you may not know what sealant is, but you do know that if you're painting something, you're painting the surface of it. And if you're painting the surface of it, then you're doing an area problem. So this is an area problem. It says she charges $7.50 per meter squared, and how much will she charge to paint the driveway? So we have to figure out the area of the driveway, and then we can figure out what she charges. So if you look at this shape, it's clearly not a basic shape, but it's a composite figure, meaning it's made up of two or more basic shapes. So the way we deal with them to find area is we cut them into basic shapes. So if I draw a line right there, I'm creating two rectangles, rectangle number 1 and rectangle number 2. And I just have to find the area of each rectangle and add them together. So rectangle number 1, so I'm going to highlight it here in red for you, and I need to find the length and width. So 9 doesn't work because 9 is the whole long side. 2.5 doesn't work because that's only this short piece, but 5 and 5 are the dimensions. So the area is 5 times 5, so it's 25 meters squared. So now let's look at the smaller rectangle. And again, I'm looking for dimensions. Don't have a label, don't know, don't know, don't know. Oh dear. So nothing is directly labeled, but we can use logic to figure out the dimensions. So let me clear the picture a little and show you how to find the dimensions. So for example, what is the length of this side? Well, this is a horizontal line. So this length is 5 meters. So this would be 5 meters. This piece here is 2.5. So this piece here must also be 2.5 because they have to add together to give me 5. So one dimension of that little rectangle is 2.5 meters. So let's look for the other dimension. So this time I'm looking for the vertical dimension like this. Well, I know that this length here is 9, and this chunk of it is 5. So 9 minus 5 would mean that this piece here would be 4, and that's the same as this rectangle dimension. So that second rectangle is 2.5 by 4 meters, which gives me 10 meters squared. And therefore, the total area is 25 plus 10, which is 35 meters squared. So if she charges $7.50, $7.50 for 1 meter squared, and this is 35 meters squared, multiply them together, she charges $262.50, which is B. Okay, looking at the next question. It says, consider the square below. What is the area of the shaded part of the square? So obviously an area question, and there's a square here. So let's start by finding the area of the entire square. So again, it's a square, so if this dimension is 6, then this dimension is 6. And the whole thing has an area of 6 times 6 is 36. So the entire square is 36 centimeters. Now look at your options. Could I possibly have shaded 36 centimeters squared if that's the whole shape? Well, no, I didn't shade the whole shape, so I can cross off A. So which one is left? Well, in this diagram, we've cut the square in half. So let's cut the square in half, and we know that this half of it is shaded. Well, if I cut the square in half, then each half is 18 centimeters squared. So this is 18. Now, I know that I've shaded more than 18 because I've shaded 18 plus a bit more. So if I now look at my options again, I've shaded more than 18. I've shaded more than 18. So the only thing left is that I must have shaded 27 centimeters. Now I want to show you how to do this again. Similar method, but if this isn't a multiple choice the next time you see it, you still should be able to get an answer of 27. So here's what you would do. Again, we know that the entire square is 36. If I cut it in half, then this must be 18, and this must be 18. Now, as you can see in the diagram, not only did I cut it in half like this, but then this upper triangle was again cut in half. So instead of saying 18, I'm going to cut that in half. So half of 18 is 9. So the parts that I've shaded are 9 plus 18, and 9 plus 18 is 27 centimeters squared. So you don't necessarily need to do process of elimination. You can get the answer without multiple choice. Okay, so let's look at the next question. So question 34 is a geometry question. It says, consider the diagram below. What is the value of x? So let's carefully make sure that we identify where angle x is. It's right here. It's not part of this triangle. It's outside of the triangle. But the triangle is obviously important because when you look at the triangle, it's got 2 of its 3 angles labeled. So I know that I can find this angle here, and hopefully that'll help me find x. So what is this green angle? Well, again, the sum of the angles in a triangle is 180 degrees. So if I subtract 23 and I subtract 56, I'll be left with just the green angle, which is 101 degrees. So I know that this is 101 degrees. Now don't get fooled by the fact that one of the options is 101 degrees. I didn't find x, I found this green angle. So how can I use the green angle to find x? Well, let me demonstrate here so that this is clear. So we have a straight line. If something rotates through a full straight line, so again, from this side all the way through to the other side, they have rotated through 180 degrees. And we know that because we know that it's exactly half of a circle, and a circle is a 360 degree. So again, when you rotate through a straight line like this, you're rotating 180 degrees. Now, this straight line, let's go back to the diagram. Here's the straight line that x sits on. Oh, that was messy, but whatever. Here's the straight line that x sits on. And that straight line has a line cutting into it like this. And on this side, we have 101 degrees. And on this side, we have x. So again, if I rotate through here and here, I've gone 180 degrees. Well, this is 101, so this must be whatever's left over. So 101 plus x is 180. So 101 plus x is 180. So just subtract. 180 minus 101 is 79 degrees. So the answer is C, 79 degrees. Some of you may also know something called the exterior angle theorem, which says that if an angle is exterior to a triangle, so here's the triangle, and x is outside of that triangle, then this angle is equal to the sum of the other two. But I don't like teaching things that you have to memorize. I much prefer that you understand the process of how to find the angle than memorize rules that might get messed up later. So I hope that was clear. Okay, let's look at the next question. So again, we have an angle-based question, so geometry. It says, consider the diagram below, which equation is true? So obviously in the diagram, you can see that you have parallel lines both here and here. So those are probably going to come in useful. So let's just look at each of A, B, C, and D and see what we can make sense of this. Is it true that x equals z? Well, it doesn't look true in the diagram. It looks like z is smaller, but let's make sure. So again, we have parallel lines here and here. X and z form this C pattern. So if you turn your head slightly, you should see a big capital C like this. And the rule is for a C pattern that the elbows of the C are adding to 180. So in this case, x plus z adds to 180. So is it true that they're the same? No, it's true that they add to 180, not that they're the same. So it can't be A. Let's look at what B says. So B says, is it true that W equals Y? Well, it certainly doesn't look like it's true. And if I think about all my parallel line theorems and all my other theorems, I'm not sure how to relate Y to Z. I mean, look at what I've just drawn. Something like this. That's definitely not a shape that we studied. It's not an F pattern. It's not a Z pattern. It's a W pattern. So there's no reason at all why W and Y would be the same. And it really doesn't look like they're the same. So I'm crossing that one off. Next, is it true that Y plus Z equals 180? So here's Y and here's Z. So what do we notice? Well, I have a parallel line here and a parallel line here, and there's Y and Z. So if you look, I have another C pattern. This time it's a backwards C, but again, the elbows of a C add to 180. So in this case, Y plus Z would equal 180, and that's exactly what it says here. So this must be a true statement. Okay, so let's double check, since we have time, what D says and make sure we understand why that's false. D says, is it true that W plus Z equals 180? Well, if I look at W and Z, I see this pattern. There's Z and there's W. That's a Z pattern like this. And in a Z pattern, the armpit angles or elbow angles are the same. So W would equal Z, not add to 180. So D is not true. And again, I already knew that because I knew that C was true. So I hope that helps. There are a couple more questions, which means there's one more video, and I'll see you there.